Now, 0, 3 is your next coordinate. 0, 3 is your next coordinate. Can you kind of see half of a parabola being formed? Now, you should understand that a parabola is symmetrical and that it will reflect over here. So that green dot, do you understand it's going to reflect over to here? So if it's 1 away here, it's going to reflect to 1 right there. So look at that. What is the 3? What's the output for 3 look like it's going to be? 0. Shouldn't these two numbers be the same answer? Because aren't they both 1 away from 2? So the answers would be the same. Look at this one. If I flip this one over to here, for 4, what should we get? 4, 3. Shouldn't these two answers be the same? Do I have to take the time to do all this work? No. Could you? Yes. But with the parabola, you don't have to. As long as you get one side, you can reflect it over to the other side. Now, could I have done 3 and 4 to start with? Yeah, but these are easier numbers, so I do the easier numbers and then reflect it over. Can you see a parabola?
Yeah.
A parabola. Now, a parabola is kind of like a U shape. It's not a V shape. Do not make a V shape out of it. It's a U. So I always like 5 coordinates. You only have to find 3 of them and then reflect the other 2. Now, the next step is important points on a parabola that are very important throughout this whole chapter. Your first important point is that one. That is called a vertex. It's the turnaround point. In this particular problem, what's the coordinate? Looks like 2, -1. Is it always 2, -1? No, depending on the parabola. But vertex is that point right there. Okay. Another important point is that right there. That's called your y-intercept. Why is it called the y-intercept? Where it's where the graph intercepts the y-axis, or hits. That coordinate is 0, 3. So we have our y-intercept or vertex. What do we say this thing's called? Line, or you also call it the axis. I think your book used axis of symmetry. And the axis of symmetry is always x equals, because it's a vertical line. And in this situation, it's x equals what? 2. So there's a lot of things you need to label. And the last one are these 2 points. See those 2 points? They have 3 different names. One of them, the most obvious, is called your x-intercepts, because they cross the x-axis. The other 2 names are 0. They're the zeros. You'll see why later. They're also called the roots. It could have 3 different names. X-intercepts, because they're where the graph crosses the x-axis. They're right there. They're also called the zeros or the roots. And in this situation, there's 2 of them. Looks like one of them's 1, 0. The other one is 3, 0. All parabolas will have a vertex. It's the turnaround point. All parabolas will have a y-intercept. Will all parabolas have x-intercepts? No. Could I draw a parabola up here and never hit it? Or up one upside down here and never hit it? Parabolas don't always have x-intercepts, or zeros, or roots, whatever you want to call them. Will all parabolas have an axis of symmetry? Yes. Again, make a table, only do half the values and flip them over. But in order to start the whole thing, you have to go back to -b over 2a. You have to make the line of symmetry